Okay, so let's try doing another example. And as we are moving forward, you should be able to solve your assignment question in 15 minutes, not more than that. So now we have a scenario. We have a cache containing 64 blocks. Okay, so we are given a cache size. And each block contains 16 bytes this time. Okay, to what block number does address 1200 map? So for example, we are running an instruction. So processor is requesting a data that is placed at 1200 address. Okay, so 1200 address must be placed somewhere in the main memory or either in the cache. So recall the formula. We need to determine the block number. And block number in a cache, where will this 1200 address data will be mapped in a cache. So this is a formula. So we first need to determine the block address in a memory, because I mentioned that the cache and the memory both are arranged in the form of blocks, and each block may have different sizes. So in this example, we are dealing with the block size of 16 bytes, which means 4 words. And LW, what does LW request? We request one word, right? LW request read one word only. So which means that when we have to copy the data from memory, the entire block is copied into cache. So instead of one word, the entire 4 words of block will be copied into the cache. Okay, so here it is asking the 1200 is the address, first of all, which block in the memory this 1200 will belong to. And then we have to copy that block into the cache, and which block in the cache will it be placed. So these are the 2 important questions here. So to determine the block address in a memory, how do you think we can determine the block address in a memory? So you are given 1200, so which is the byte address that LW instruction has requested, and you need to divide it by the bytes in a block, total number of bytes in a block, which will give you the block address in a memory. And these symbolic representation indicates that you have to floor it down, round it off. Okay, so here the value is 1200 that is being requested. There are total 16 bytes in a block, so it's a 75th block in a memory. Okay, so that 75th block in a memory has to be copied into a block in a cache. Now we need to determine which block in a cache. So this is the formula for this one. So what we do is simply 75 modulo 64, which means that it will be mapped into the block number 11 in the cache. And this is exactly how you should be calculating and completing your assignment. Okay, so if I were to ask you what will be the index, what is the width of the index field in a cache? What will be the width of index field? 6 bits. Why? Because there are 64 blocks in a cache, so we can simply represent 64 in the form of 6 bits, right? So 1, 2, 4, 8, 16, 32, and if you set all of them to 1, then we can represent 0 to 63 in 6 bits. So 6 bits is the index field. Offset bits. So offset bits signifies the total number of, each byte in a block. So how many bytes are there? There are 16 bytes. So we can represent 16 bytes in 4 bits. So this is the 4 bits offset field. This is 6 bits index field, and the remaining upper bits will be used as a tag bits. Okay, so we have the activity coming ahead next. So you should know how to calculate the tag field, index field, and the offset field. Yep. Can I explain what? This thing? So this is the formula, 75 modulo 64. How do you calculate it? It's actually 75 divided by 64, and the remainder is the outcome of this expression. So when you divide 75 by 64, or let's say when you divide 8, let's take a small number, 8 divided by, let's say, 4. So when you divide 8 by 4, what is the remainder? It's 0, right? When you divide 9 by 4, so 4 times 2 is 8, and the remainder is 1. So the modulo, this expression's remainder will be 1, okay? So this is how it is calculated. Yep.
What exactly is the table on the bottom?
So it tells you that the address, what is the byte offset, how can you access a specific byte within the block, okay? So byte offset here is only 2 bits in this example. Why 2 bits? Because there are 4 bytes in a single word, right? So you can access any particular byte, 0, 1, 2, and 3. And then we have the index field, which helps us access a particular block, and the tag field, which helps us match the tag bits to identify whether the data requested is the one which is present in the cache. So here, after having this information, you should be able to identify, because 64 blocks can be easily accessed with the help of 6 bits, right? And the upper level bits are tag bits. But in order to identify what are the total tag bit size, you need to determine the offset field also. So out of this 32 bit, so there are 4 bits for offset, because each block has 16 bytes. How you can access each individual byte? With the help of 4 bits, right? 0 to 15, you can represent in 4 bits. Okay?
Total 30 bits.
It's total?
Yeah.
32.
4 plus 6 plus 20.
So 0 to 31. Okay, so yeah, it should be 22. 10, from 10 to 30. Yeah, okay?